This conference will now be recorded.
All right, so final is a keyword in Java that is usually used to make it constant. Okay, constant, in other words, unchangeable. Okay, final should be used to make any aspect of a program constant or unchangeable. So you can apply the final keyword to variables, methods, and class. Okay, you can apply this keyword to any one of these variables, methods, and class. Okay, now if you have a final variable like this, the value of the variable remains same, 20. It will never be changeable. Okay, if you try to change that value, you'll get an error. Okay, that's the first thing. The variables, once you initialize a value, it can never be changed again. Okay, now you can also apply the final keyword to a method. Okay, you can also apply the keyword final to a class. Okay, so let's see what exactly final does. Now, first thing you guys need to ask is, why do we need final? Okay, now what does the term variable mean?
Whose value changes.
The value changes, right? The value changes. Now you apply the final keyword to a variable, and what happens? You can't change the value anymore.
It's going to be constant.
It will be constant. So final, when you apply to a variable, it basically goes against its very basic purpose, which is changing values. Variables meaning the values will change. You apply the final keyword and you beat the purpose. The main definition of a variable is lost. The moment you apply final keyword to a variable, the main definition of variable is variable means varies, changes, and you can't change anymore. Okay, if you apply final keyword to method, you cannot override, which is what Java feature is this? What Java feature is this? Overriding?
Runtime polymorphism.
Yes, it's a polymorphism. Okay, you apply final keyword to a class and you cannot extend anymore. Okay, now extending meaning which oops feature is this?
Inheritance.
Inheritance. So my question to you guys is this thing: why would you need final at all when final keyword basically stands everything against Java? Variables meaning change values. You apply final and you can't change anymore. You apply final to a method and you kill the polymorphism feature. You apply final keyword to a class and you kill inheritance feature. So if you really see, final is the one thing that is exactly opposite of what an object-oriented program is. Whatever the basic principles of object-oriented program is, you apply final and you totally beat that purpose. Okay, so it is totally against what Java stands for. So the question is, why would we need that? Okay, why would we need such a feature in Java programming language, which basically stands everything that Java program teaches us? Okay, let's see why we need that. Now, applying to a variable, the name of the company, right? Amazon, Bank of America, AT&T. Okay, These are the names that have stuck around for decades since the company was founded. Okay, now you as a programmer want to make sure that this information, no matter what happens, is never changeable. Okay, is always constant. That's when you use the final keyword on a variable. Okay, you don't want any programmer who is trying to trick everyone with this program and display some other name. Okay, so let's say final string company name. Okay, and you have the name as Bank of America, and somebody decides to fool with this program and begins making changes to the company name in a method. Okay, now all of a sudden whoever calls the withdraw function in your company, they will end up changing the company's name to something foolish. Okay, so sometimes what I mean to say is sometimes you will have some information which never has to change whatsoever. Okay, company's name is one of the example. The name of the company will never change as long as that company doesn't go bankrupt. Okay, as long as that company is running, no one will ever dream about changing that name at all. Okay, so to avoid any developers from making changes to this particular variable, we decide to make this as final. So when we make this as final, no one will ever be able to change this variable. Okay, so that's why we need final for a variable. Okay, is that clear?
Yes.
Yes.
Okay. Now let's see why we need a final keyword for method and a class. Okay, we'll see why we need for a method and a class. Okay, let's take the yesterday's example. All right, so now there is a method called stop, which is overriding here. Okay, so there is a method that is implemented in the base car which says stop method, and now someone decides to fool around with this program. Okay, now if you are not the owner of this program, you can still fool the system and make a change. Okay, how you do that is by doing overriding. Okay, if someone is trying to create a class, if someone is trying to call your method, okay, so this is a perfect implementation of the feature stop. So the car program did their job. Okay, whoever wrote the program for the car class, they did their job perfectly. Okay, when someone says I want to stop the car, your car slows down and it stops. Okay, so let's say this is done by programmer 1. So programmer 1 has the rights to do any changes in this class. Okay, programmer 1 has all the permissions, all the responsibilities, all the rights to make a change here. So programmer 1 made a very good job and implemented the stop functionality perfectly without any mistake. They implemented the stop method perfectly. Now then comes the programmer number 2. So programmer number 2 doesn't have any permissions or any rights to make changes to this class. So what the programmer 2 decides, I will make changes to that stop method by extending the car class. Okay, so when you extend the car class and you do this, overriding meanings, you are going to override whatever the meaning of stop method is, and you're going to rewrite the code yourself. So you decide to play with them, and what do you say? Go full speed. When the customer is trying to stop the car, you go to the maximum speed. Now this programmer is fooling with your system. This programmer is trying to trick your system. Okay, now the customer on the other hand has no idea what's going on. Customer knows, okay, this is a customer who is using these classes. Customer has no idea what's going on within your company if the programmer, the new programmer, is trying to fool the system or whatever, right? So customer honestly tries to stop the car, and in this case everything works fine. The car slows down and stops. Okay, perfectly fine. Now if customer buys the Nissan car, and this is what will happen. The new program that you created, it totally overrides what is the meaning of a stop car. The meaning of stop car was overridden by the Nissan program. So whoever is using the Nissan program, they will have a totally opposite experience of a stop class. Okay, so you as a programmer 1 have to decide, how do I make anyone else to mess with my system? Okay, how do I ensure no one will ever mess with my perfect program? Okay, so if you are the programmer of this class and you are very, very sure that this program is written perfectly, the stop method has been written perfectly, and no one should ever try to mess with this program or this method in particular by extending the car class and overriding the stop method. Okay, if you want to do that, what a programmer 1 does is they will declare the method as final. So once you declare the method as final, the other programmer will never be able to fool with your system, mess with your program. Okay, no one will ever mess with your program because you made it as final. Final should be used on a method if you are very sure that this method that you have written is perfectly implemented and no one should ever make any changes to this. No one should ever mess with this method ever again. Okay, a perfectly written program is what a perfectly written method is what you decide to make as final. It applies to everything. Imagine if this is a calculator class. Okay, okay, so you have a calculator class. Now in your opinion, is this calculator program doing a perfect job of adding 2 numbers?
Yes.
Will adding 2 numbers ever change now or 100 years in future? Will the way you add 2 numbers, will that ever change in 100 years in the future?
No.
No.
No. When someone gives you 2 numbers and asks you to add, this is how you do it. You take the first number, second number, and you add it. This is a perfect method, isn't it? Do you ever expect this to change maybe 1 year down the line, 100 years down the line? No.
No.
So this is when you decide to make this method as final. This is when you decide to make this method as final. If you're very, very sure that this is the proven way of adding 2 numbers and no one will ever have to change this method ever again, that's when you decide to make a method as final. A perfectly executed method, a perfectly programmed method is what you declare as final. Okay, because we don't want any smart programmer who is trying to, manipulate your. Okay, if someone tries to mess with your system, they can do like this. They can extend your your class, and they will decide I'm going to change the meaning of add. If someone asks me to add two numbers, what I'm going to do is I'm going to give them this. Okay, so some unknown innocent person, accountant, is trying to use your latest upgraded calculator, okay, latest calculator in the market. So they go in the market and they buy the latest calculator, and for their surprise, they will end up with a totally different experience because one of your programmer decided to mess with your company and decided to override the system. Okay, they totally change the meaning of how you add the numbers. So to avoid this kind of mess, we declare them as final. Okay, is that clear?
Yes.
Now, the last question is, when do you declare the class as final? Okay, now if you have four methods here, subtract, multiply, divide, like that. Okay, so you have four methods. Okay, so you have four methods. Now, as a whole, not just one method, isn't the entire program perfect? In your opinion, is everything you see in this class, is everything perfectly executed and there will never be any change in this program ever? Not just one method, but every single method?
Yes.
That's when you decide to make the entire class itself as final. Okay, you decide to make the entire class as final if every single thing you have in this class is perfect and no one will ever have to make a single line of change. Okay, if no one has to ever make any changes to this program from top to bottom, everything is perfect. That's when you decide to make the entire class itself as final. By doing so, no one can extend it. Okay, no one can inherit this program, and by not inheriting, no one can attempt to override either. Okay, if you want to override, what you need to do, you need to extend first. Once you extend, then you can override. Okay, then you can override the meaning of this method. The main purpose of extend is so you can reuse these methods, and whenever it is necessary, you can modify the existing feature. Okay, something unpredictable. Okay, but by doing the entire class itself as final, you can't extend, and thereby you cannot override. Okay, so as you know, overriding only happens in parent and child class, isn't it? Overriding only happens in parent and child class. If there is no extend, you can't override either. Okay, so that's when you decide to make it as a final. Okay, so for variable, why do we need this? If there is some information that will always remain the same, like a name of your company or the name of your product, we never assume the iPhone will ever change. Okay, iPhone's name will ever change. iPhone will always be called iPhone. iPhone X, 10 different version, but it is always an iPhone. Microsoft will never change its name unless someone buys it or they go bankrupt. The name of the company will remain same. The name of the popular product will remain the same. Those kind of information you declare as final. When it comes to method, if the method is perfectly implemented that you believe will never be changed or will never be required to change, that's when you declare the method as final. When it comes to class, if you ever come across a program that top to bottom everything is perfectly executed, perfectly programmed, then declare the entire class as final. Okay, if you declare the variable as final, you cannot change. If you declare the method as final, you cannot override. If you declare the class as final, you cannot extend. Okay, so that's what you're looking forward to. Cannot extend, cannot override, and cannot change. Okay, that's what you have to use for final. So is that clear?
Yes.
Now, just to give you an example, there is one final program that you guys have been using from day one. Okay, which is the one class you use 90% of the time in your program? Which is the heavily used program so far?
Main.
Main is not a program, it's a method. Which class, which data type do you heavily use?
Address.
Is address available in every single program?
No.
Public.
Think carefully. Which data types? Okay, name some data types and tell me which are the most common you use when you declare variables.
Integer.
Int, string.
String.
Yes, int, string, and all. So is int a class?
No. String
It's a
is a
primitive data type. Okay, it's a primitive data type. It's not a class. So the next highest used is string. Isn't string a class?
yes.
String is actually a final program. You have been using string from day one. So you guys have been using the final class from a very, very long time. Okay, so this is a string class, right? If you go to this class, the string class is actually a final. Okay, because the developer, the founder of Java, they decided string class is a perfect class. Whatever they wrote inside the string class, okay, it is perfectly executed. Every single method, every single variable, whatever you see in this program, everything is perfectly executed. And no one should ever try to change the string program. For that reason, what did they do? They declared the string class itself as final. Okay, so this is the Java program that you guys have been using from day one, string class. Even system is a very common program, isn't it? You guys use the system program every day, right? System.out, sysout.
Yes.
Even that's the final. Even system class is final. So most of the programs that you guys have been using without your knowledge, whichever the developers felt are perfect, they were all declared as final. Okay. All right, so let's go with static now. All right, so this is one variable that we discussed in chapter 3, type of variables. Okay, so can anyone name what are the type of variables? The 4 type of variables?
Instance variable, class variable, local variable, and parameters.
Very good. So why do we call, does anyone know what's an instance?
Non-static variable.
It's an object.
It's an object. Okay, so if a program has something like this, okay, if a program has like this and you have name int age, okay, now if I create 5 objects of student s1 equals new student, Okay, if we have 5 objects, how many copies will be there of name and age?
5.
5 different.
5 copies. Okay, so 5 objects. Remember I told you object is also referred as instance. Okay, instance meaning copies. Okay, so how many instance of student class do we have?
5.
5.
5. How many objects of student class we have?
5.
5. Okay, we have 5 instance of student class and 5 object of student class. Remember, object, whenever you hear the term instance, we are talking about their objects. Okay, so every time you create like this, typically this is what happens in the memory. Okay, if this is your class, you will end up creating 5 objects in the memory, and each one of them with their own copy. Okay, S1, S2, S3, S4, S5. Okay, so you'll end up creating 5 objects. Name and age. What are their values?
Null.
Null, 0.
Null and 0. Okay, this reference is being pointed by S1 variable. Okay, similarly, you will end up with 5 such copies. 2, 3, 4, 5. Okay, so there will be 5 copies. Each one of them with their own personal copy. Okay, that's what instance variable is. Instance variable is that information which is tied to every object or every instance that you ever create. Okay, if you say student S1 equals new student, every object like S1, S2, S3, they all will get their own copy, name, age, name, age, name, age. Everyone will get their own personal copy of name and age. That's why we call them as instance variable. Instance variable meaning for every instance that you create, student S1 equals new student, these variables are their private copies. Okay, that's why instance variable. Does everyone remember that? Understand that?
Yes.
Yes.
Now, first question is, why do we need name, age, personal copy of every object, every instance?
Different name of student and age.
Exactly.
Because all of
Exactly. So if you have 5 students, will every student's name and age will be same? If you have 100 students, right? So not every single student's name and age will be same. Maybe first name might be same, last name will be different, age might be different. So you will never come across any scenario where everything matches. Okay, now for that reason instance variable makes sense, because sometimes if our program wants to create data, okay, or create a digital simulation of 5 students, all we had to do is create 5 student object, and each object will get their own name. Okay, first student will get the name John, second student will be Jane, and so on. Okay, so every object will have their own personal name and age. Okay, that's why we need instance variable in Java programs. But here is the next question. Will anytime, let's say we are dealing with 1 million customers of Bank of America. Okay, so you are dealing with a banking app and you need to manage 1 million customers. So let's say you have to create 1 million Bank of America customer objects, 1 million. Is there any information for all the bank customers, Bank of America customer, to have one thing in common? What's the one common thing you might think of? Will everyone have the balance same?
No.
Will everyone have their account number same?
No.
How about name, customer name? No. So if you are writing a bank program, name, account number, and balance, are they instance variables? Because everyone has their own value for the balance and number and name.
Yes.
Right? How about the bank name itself?
It will be same.
Bank information is bank name for Bank of America project. Will that change from customer to customer?
No, it's the same one.
No.
It's the same one. So does it make any sense if I create, let's say you're writing this for some university, okay? You're writing this program for Harvard University, okay? And you have something like this, university name. Now, if I create 5 objects, what will happen in the memory? If it is an instance variable, how many copies of university name will be if I create 5 objects?
5.
All 5.
5 of them. Now we know all their values are same. Okay, you are writing an app for Harvard, and that will never change. So isn't that a waste of memory? If this information is going to be common for all the students of the university, isn't this waste of memory?
Yes.
Yes.
Okay, for that purpose, we have something called static. Okay, so static variables are what we call class variable. Okay, if instance variable belongs to each and every instance, okay, or objects, static variable belongs to the entire class, not for individual instances, but for the entire class, and hence the name class variable. It applies to the class, not to individual objects. That's what it means. Okay, so if you declare the university name as static, you won't be dealing with this. Okay, every time you create an object, you won't be creating a separate data for every single instances. Okay, these are not instance variables, these are class variables. These are not object, these are not tied to every object, but they belong to the entire category. Okay, so what you will have something like this. Student class will have university name, okay, and this particular information will be shared by everyone. It will be shared by everyone. Okay, because this information is not for individual student. Okay, it's not like we are going to change the name of the university from student to student. Okay, it's not like we'll call it Harvard 1, Harvard 2. No, everyone who is studying in Harvard, all their university name will be displayed as Harvard. So there is no point in having this created for each and every student. So what we do is we keep it here. Okay, so what we call static, okay, static is a class variable that is shared by all the objects of the class. Okay, class variable that is shared by all the objects of the class. So S1, S2, S3, S4, S5, all the instances or all the objects that you see here, they all will share this one information. They don't have to maintain them separately. Okay, they all will share this one common information. Okay, does that make sense? Why we need static? Any information that you will require to share or is common throughout all your objects, that's what you declare as static. Is that clear?
Yes.
So the next question is, how do we access them? For instance variable, if you want to access name, what did you do? If you want to access the name variable, how do you do that?
We create an object first.
Yes, you create an object and you use the dot operator, s1 dot name. This is how you access that. So the question is static tied up to one object in particular?
No.
No.
No. Okay, so is static member applied to one object? No, it is shared by everyone, isn't it? It is the one common thing. Okay, this is one common information that every student have access to. So does it apply in their own personal space or in the common space?
Common
Common
space.
space.
Common space. So the way you access static variable is you don't need to create object. Okay, since static member doesn't apply to one object alone, you do not have to create objects at all. All you say is student.name. It doesn't apply to one object, s1, s2, s3, s4, s5. This particular variable doesn't apply to one object. It applies to everyone. Okay, and hence we don't have to create the object itself. You can just use class name dot the static variable name. That's it. This is how you access the static member. Class name dot university name. Whereas the instance variable, they apply to each and every instances or objects. Okay, this information applies to individual object like this. So if you need these information, you need to create the object first because they apply to each and every instance. Whereas static doesn't apply to individual objects, so you don't have to create object itself. You can just say class name dot university name. That's the reason. Okay. Okay, so you have an instance variable which applies to individual objects, whereas another thing is class variable. It applies to every objects. Okay, so let's see how they behave. All right, so we have two student object, and I will set values for each one of them. Okay, I will set John for this first object, and for the second object name I will set as Jane. Okay, now if you create two objects, both objects S1 and S2, they have their private name copies or shared copies?
Private copy.
Private.
Right, so they will have their own private copies. S1 is pointing to 1 1, it has its own private copy of name. S2 is pointing to 2 2 2, it has its own private copy. Those are instance variable, okay, non-static ones. For every instance you get your personal copy. For every instance you get your personal copy. For every object you get your personal copy. Okay, remember, object and instance, they are both same, it's a synonym. Okay, so if I have two copies, S1 and S2, two objects, two instances, the name will appear in their own private space. S1 will have its own name and S2 will have its own name. Okay, so if I make a change, default value is Mike, I make a change here. I change John for the first copy of the name, S1's copy of name. I'll set it to Jane for the S2's copy of the name variable. Okay, when I do sys out for both of them, so what will it print?
John and Jane.
John and Jane. Okay, so we have John and Jane. Now this time we'll also print the university name. Now let me tell you one thing. You see this warning, yellow line means
Warning.
warning. Okay, meaning it is acceptable, but it is the wrong way to use it. It is acceptable, but wrong way to use it. Okay, you can call the static variables with the objects S1, S2, and you can also call it with class
Just
name.
this.
Last name.
Okay, you can call it with objects or you can call it with the class name, and this is the right way to use it actually, and that's why this line doesn't show you any warning. These two show you warning. It means they're trying to tell you that you might have mistaken the university name variable. Yes, you can access it with your object S1 and S2, but this particular information doesn't belong to individual object S1 and S2. That's why it is trying to warn you. This, on the other hand, they are their own copies, right? The name is an instance variable and they are a personal copy of S1 and S2. So this is the right way to access name variable. But when it comes to university name, you have to access it via class name. This is not the right way to access it. There is no problem. It will still allow you to print university name. But you might be mistaken. It doesn't apply to one object, S1 or S2. It applies to the entire class as a group. It is a shared information. Okay. So when you print this, you can access Harvard, the value of university name, with individual objects or the class name. They all are same. Okay. Now what happens if you change these values?
Error.
You don't have any errors. You can still change it. Okay. ABC, DEF. Okay, you're changing the university name. Let's say okay, everyone changed the university name, just like S1, S2. We changed John using the S1.name. We changed Jane using S2.name. Okay. The other variable that we have, the static variable, we are changing that as well using the S1 object, S2 object, and student object. Okay, so let's see what it will print when you change using all three handlers. PQR, what was the most recent name, university name change to?
EQR.
Was the most recent. So once you made a change here, it reflected to everyone, to S1, S2, student, everyone. The reason is this particular variable is shared between every object, S1, S2, and S3, everyone. Okay, you can have as many variables as you want. The name attribute was a personal copy of S1 and S2. So whatever changes you did, it applied to their own personal copies. So when you print them, you got different values, John, Jane. But when it comes to the shared variable, static variable, or class variable, everyone tried to change that variable. S1 tried to change it to ABC, S2 tried to change it, DEF, and student also tried to change it. Everyone tried to change the shared variable. Since it is shared, whoever made the changes the latest, the most recent, that value will be permanently reflected for everyone, S1, S2, and student. That's the value that will reflect. Okay, so it's something like, if you want to access the university name, you can just say s1.harvard. Anyone can access this shared variable. Anyone from the same type, student can access, S2 student can access, S3 student can access, anyone can access university name. Okay, now if s1.university name is changed to ABC, okay, S1 attempts to change the name from Harvard to ABC. Okay, when S4 tries to access the university name, where will it go? Here, is there any university name in your private copy?
No.
No.
It is here, common, shared by everyone. So when s4.university name is what you print, what value do you get?
ABC.
ABC. So whatever changes S1 did, S4 could feel that, isn't it? Whatever changes S1 did, when you do a sys out for s4.university name, you can see that change. Because this particular variable, university name, is shared by all the objects. Okay, if someone makes a change to university name, all the other people can see that. It impacts everyone. It's a shared variable. On the other hand, when you change s1.name to John, will S2, S3, S4, S5, all their name will change to John?
No.
No, because name is a private copy of every variable. S1 has its own name, S2 has its own name. So if S1 makes a change to John, where will you change it?
Just in 111.
Just in 111, you change the name from John, null to John. So if S2 wants to look at its name, will it see the result as John or null?
Null.
It will see as null. Okay, a private copy is what instance variable is. Every object will get its own private copy. For every instance, you get one variable each. Static is a shared variable. If S1 makes a change to university name, everyone will see that impact. Okay, that's what shared variable is. It is shared among all the objects of the student class. It is shared among all the objects of the student class. Okay, so for this example, This is before, after. Before you make a change, we'll print what is the university name. They all will say Harvard. Now only one object will dare to make the change, and you will see that even S2 and S3 got impacted. Even they will start seeing the new name ABC, not Harvard. It was Harvard for everyone. One person made the change. S1 made the change to ABC. Now for everyone, it is showing as ABC. Okay. The same when applied to name, which is not a static shared variable, it is an instance variable. Every object, S1, S2, S3, they have their own copy of name. When you do this, instance variable are not shared variable. What will it print the first time? What will it print the first time?
Harvard.
Yes. We are talking about name. What is name?
John.
John. So Mike.
The value of John is changed here.
Mike.
Before changing your printing, guys, pay attention here. Before changing the value, you're printing here. So when you created the object, what was the default value for name?
Mike.
Mike.
Pay attention, guys. It is Mike. Default value is Mike. So before you make any changes for S1, S2, S3, what will it print?
Mike.
Mike.
How many times?
Three
Three.
times.
3 times. Good. Now S1 will change its name from Mike to the new value John. This time what will it print? Remember, this is an instance variable, not a static, not class variable.
John, Mike.
John, Mike.
John, Mike, and Mike. The first 3 times Mike, 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 default values. The second time, S1 is the only person who changed its name, and it will reflect for only S1. It will not reflect to S2 or S3 because everyone have their own copy of name. If S1 makes a change to the name variable, its own personal copy gets changed, not others. Others will still remain as Mike and Mike. Now, do you guys understand the difference between instance variable, class variable? How it behaves,
Sir. Yes,
how
sir.
it is stored in the memory, and how it is created? Is that clear about the instance variable and the static variable?
Yes, sir.
Yes, sir.
All right. So there are certain rules that applies to static versus non-static. Okay, they are non-static, meaning instance. So there are certain rules on how you can use them. Okay, let's see what they are. So we'll have 2 copies: a non-static variable, instance variable, and a static variable. Static keyword also applies to method. Okay, so you have method 1, and you have method 2. Again, one is static, one is non-static. Okay, non-static variable, static variable, non-static method, and static method. Okay, this is the options you have. Now what you can do here, what is the purpose of methods?
To manipulate the data.
To manipulate the data, and the data in this program is,
Instance.
name them.
Name.
Name and universe name.
And university name. Okay, these are the data, and these are the means to change this data. Okay, Now let's see what are the rules. Typically, through the methods, we change the name. Okay, we change the value of the data. Okay, that's the main point of purpose of methods. So the rules are: a non-static method can use static and non-static both. You can use both. A non-static method can access static as well as non-static member. Okay, but when it comes to static method, you cannot access non-static. Okay, this is the rule. You cannot access the non-static. Okay, static member can only access another static member. That's it. As simple as that. One static member can only access another static member. When it comes to non-static member, they can access everything. They can call non-static member as well as static member. Okay, so a simple thumb rule you need to remember: static member can only access other static member. As simple as that. Just remember this one line. Okay, static member can only access other static member. So when I say member, what do we talk about when we say class members?
Variables and methods.
Variables and methods.
Variables and methods. Okay, so these are what we call class member. The student class members are the name variable, the university name variable, the method called method1, the method called method2. Okay, variables and methods are what we call class members. Now, a slight change is we have static members and we have non-static members. Okay, we have static members and we have non-static members. Okay, since methods and variables always work with each other, from the method you change the value of a variable and you try to print the variable. Okay, so either you are reading the variable or you are changing the variable, one of those two. Okay, either you're changing or you're reading. So it is very important to know who can call what. A non-static member can call anyone. They can call non-static as well as static. A static member can only call other static member. In this case, university name. You cannot call the non-static. Okay, so remember this one line. This is a limitation. Other than this, you can call any methods, any variable, however you want. Other than this rule, you can call any method, any variables, any way you want. When it comes to static member, they should only access other static member. Okay. So here, if I create method 3, so the question is, if I have to call method 3 from here or here, who is capable of calling it? This is a non-static member.
Method one.
Method 1 is the only person who can call it. Method 2 cannot. Okay, just like name. Name is a static member or non-static member?
Non-static.
It's a non-static member. So from a static method, you cannot call this. Similarly, if I call method 3, even that's an error, because method 3 is non-static. Okay, you cannot call non-static members, be it a variable or be it a method. Okay, here you can call everyone, no restrictions. You can call method 3, you can call method 2, anything is okay. Okay, non-static, static, non-static, static. Anyone can be called from a static member. Sorry, from a non-static member. From a static member, only static variables, nothing else. Okay, you can also call this. Okay, so only the static variable and static method, not these. Okay, so easy way to remember this is just remember this part. One static member can call other static member. That's it. Okay, this is the restriction. Other than this, everything is okay. Other than this, any combination is okay. Right? So any questions on static? How to call it? Student dot university name. No need to create object. Student dot method 2. No need to create objects. Okay, you can do sys out. Directly calling university name, directly calling method 2. Did I create an object of student here?
No.
No. Okay, because static members do not belong to one instance or one object. They belong to the entire class. They belong to everyone. And that's why you can directly call it. Okay. So this is how you can call static variables and methods. And this is the restriction on who can call whom, which class member can call whom. And finally, this is how it is stored in the memory. Every instance variable is unique per object, per instance, but the share variable is shared by everyone. Everyone shares this one common information. Memory view, usage, and restrictions. Okay, remember these part. So, any other questions in static?
No.
All right.
This conference will now be recorded.
All right. So, one thing you need to remember is when to declare a method as static. Okay. So, typically a static method we usually use whenever it's whenever you need to create something like a utility method. Okay, so let's see why and when to use static. Okay, so you're already aware about the variable. When to declare a variable as static, you're aware about that. If there is one information that will never change from customer to customer, from object to object, it is shared by everyone, you declare that as static. When to declare a method as static, let's see that. Okay, so this is a customer, bank account customer class. Okay, so we have 3 customers. Now for all the 3 customers, the name will remain the same, right? So we declare this variable as static because the company name will be shared by all the customers of Bank of America. Okay. How about balance? Is this specific to one customer or it is shared by everyone?
Specifically one customer.
Specific for each customer.
So should it be a static or an instance variable?
Instance.
That's it. Okay, so this will be instance variable. Now, every time someone withdraws or deposit, you basically make changes to your balance. If someone withdraws, we say balance equals balance minus amount. We have to reduce the amount they're trying to withdraw. When someone does deposit, what will be your code? What change will it do to your variables?
Balance is equal to balance plus amount.
Balance plus amount. Now both these methods, they are accessing your instance variable, isn't it? Both these methods, they're accessing your instance variable. Okay, they are changing the instance variable. What if I have one more method? Okay, so let's say in balance and int account number. Even account number is unique to every customer. What if we have one more feature that allows the customers to calculate what will be their interest rate? Okay, even this is a bank feature, isn't it?
Yes.
Now, does this method is accessing, reading or changing any of the instance variables?
No.
If a customer goes to a bank and inquires, if I apply for a loan, this much rate, this much principal, this much time, what is my simple interest? Will that change customer just because they were there to inquire about a loan? Will it change the balance or account number?
No.
No. So if there is a method that is not changing or reading any of the instance variable, that is your ideal candidate for static. Okay, you need to declare a method as static if in your method body you're not using instance variable. Okay, if your method is not using your instance variable or instance method, if you're not calling any of the instance or non-static members, this method should be declared as static. This is a utility method. Okay, anyone can access that. So if you're not a customer of Bank of America, can you go and inquire what would be the interest rate if they apply for a loan? Will that require for you to be a bank customer or something?
No.
Do you need an object similarly to apply the same rule? If there is customer number 4, okay, who doesn't have any account with Bank of America, but they're just curious, if I apply for a loan, what will be my simple interest? Do we need to create an object for them?
No.
Just to inquire for customer loan?
No.
You don't, and that is the purpose of static. I'm just customer number 4. I don't have any account with you. I'm just curious. If I apply for a loan, what will be my simple interest? It doesn't require to have any object at all. You don't need object. This is what we call utility method. It is just used for utility purpose. It doesn't change your instance variables. So the rule is, if there is any information that is shared between all the objects, customer 1, customer 2, customer 3, the variable becomes static. if there is a method which does not change or read, which does not manipulate your instance variables, your non-static variables or non-static method, that is an ideal candidate for static. So do you guys understand when to use static for a variable versus method?
Yes, sir.
Okay. All right, so let's continue with arrays. Or even bank account is fine. All right, so first question. If you're writing an app, if you're working on Bank of America projects, right, you need to manage all their customers. So how many customers do you think Bank of America might have?
Million.
Hundreds of thousands. Yeah.
A lot.
Millions and millions. So if one object represents one customer and that customer's balance and account number, how many objects do you have to create? Or
Billions.
representing millions of customers?
Millions.
Millions. We have to
Millions.
create.
So do you have the patience to write millions of such objects, 4, 5, all the way to million? Do you have the patience to declare a million objects of bank account?
Sorry.
No, that's tedious. Yeah. No.
Okay. For that purpose, you have something called arrays. This is the purpose you have arrays. Array is a group of objects. Array is a group of objects. Rather than declaring a million lines which basically handles a million customers' balance and account number, you can declare just one like this. Rather than doing this like a million times, you can do something like this. Now this line is equal to doing this a million times. Okay, this one line is equal to this, like declaring 1 million objects of bank account. So first question, do you guys understand why we need arrays?
Yes.
Okay, it's a group of object. Rather than having a million reference variable, customer 1, customer 2, customer 3, all the way to customer million, rather than declaring a million reference variable of bank account, we can just declare that in one line. It's a group of reference variables. Remember, array is a group of reference variables. Okay, that's why we need it. Now the next question is, are there any differences that you see from a traditional way that we declare objects? What are the differences in declaring one object of bank account versus an array of objects?
Bracket.
There is a bracket. This sign indicates array. Array is a block, okay, and a square block, if you'd like. Okay, so these blocks or brackets is what defines as an array. Okay. On this side, you tell what is the size of the array. How many variables do you want to create? We want to create 1 million variables of bank account. That's what this line does. So the question is, other than brackets, do you see any difference here and here? creating an object and creating an array. Look carefully. Other than this block,
There's an empty constructor. Here we are passing the values.
yes, there is no constructor. Okay, the reason is when you create an array, you're not initializing objects. This is how you create objects, right? To create object, you say new bank account and you call the constructor. Constructor is called when you create the objects. Okay, so are we calling constructor here?
No.
No, you're not calling constructor. So just to be clear, array is not group of objects. Array is group of reference variables. Let that be clear. Array is not group of objects, it is group of reference variables. Okay, let's see what that means here. When you create the bank account, customer 1, customer 2, customer 3, what typically happens in the memory? Your customer 1, customer 2, customer 3, and what happens?
New object is created.
New object is created. Okay, new object is created for all three of them. Okay. This is what happens when you create three objects. Okay, when you say new bank account with the constructor, remember, only when you use the constructor here, that's when the object is created. Constructor, remember the name, constructor meaning you're constructing object. Okay, you're initializing the object. So if the constructor is missing, you're not really creating objects at all. So let's see what exactly array does. Here, I'm going to create an array with size 3. Okay, size as 3. This is not equal to this. Only thing it does is something like this. Customer group just like customer 1 is pointing to an address in the memory, customer group will point to a consecutive block of variables. It's called indexes. 0, 1, 2. So rather than creating objects, what we created is group of variables. So if there is no object existing, what is the default value of that variable? What is the value of customer 3? If it is not pointing to any reference. If an object is not initialized, then the customer 3's value is what?
Nothing.
Null.
And what does nothing mean?
Null.
It's null. So if these three variables arrays that we have, index 0, 1, 2, if they are not initialized, what are their values?
Null.
Null.
They are null. So basically this, if you want to really compare arrays and objects, this is how you need to compare. So this is an array of two size. We have two variables that are initialized and two variables that are not initialized. So an array, this line is equal to the first two or the second two.
Second two.
Yes. Okay. This array is equal to the second two. This line is equal to the second two, not the first two. The first two are actually creating objects in the memory. Here, you're just declaring. So in array, when you declare an array, you're basically declaring group of variables. Remember, I'm saying declaring. Did I say initializing? No.
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 Okay. Array, initializing array is equal to, here we are initializing an array. We are calling new, we are giving size. Initializing array is not equal to initializing group of variable. Remember, there is a very specific difference here. Initializing array means declaring group of variables, not initializing group of variables. There is a distinct difference. If you do not initialize, the values are null. If you initialize, value is not null, the value will be some reference address, hashtag 111 something. Initializing variable gives you reference address. Declaring variables gives you default value null. So when you initialize array, these group of variables will have what as the default value?
Null.
It will be null. Very good. Now, if I declare an integer, if I declare a group of integers, what are their default values?
0.
0.
Okay, it will be 0 because int default value is 0. Okay, this line is equal to doing like this. Okay, and this line array is equal to this. That's what it means. Initializing array is equal to declaring group of variables. Okay, rather than declaring a million objects like this, we can just do that in one line. In just one line, we can do that. Rather than declaring million variables, we can do that in one line. So when you just declare, values will be null. So customer group, all the variables that you have, they will all be null. Okay. So this is how they two differ. Initializing objects actually creates objects in the memory. Initializing array does not create objects in the memory. It will just create variables with default value, just like this one. Customer 3 is only declared. So what did we do? We just declared 3 variables. You did not initialize 3 variables. You declared 3 bank account variables. That's all. No initialization. Is that clear?
Yes.
Now, this index starts from the number 0. Okay, so if your array has a size of 3 and the first index has the number as 0, the last one will be
2.
2. Since you're starting with 0, the actual size minus 1 will give you the last element. if I declare this as 1000, size 1000, what is the first variable's index?
0.
0.
What is the last variable's index?
999.
999. Okay, that's all you need to understand. The first variable in this array will have index 0. The last variable will have size minus 1, 1000 minus 1, 999. Okay, so now that you understand that from from the visualization, let's look at from the program point of view. I'll declare two objects. Okay, the same example I'll explain you with initialization and declaration. It is very important because as a beginner, we make this mistake all the time. I cannot declare it here. It will just create a problem. Okay. All right, so let's see. Sits out customer 1 and customer 2. So customer 1 and 2, will that print null or some reference address? Customer 1 variable and customer 2 variable.
Some reference.
Reference.
Has some reference because customer 1 is initialized with the constructor and customer 2 is also initialized with constructor. So this will not give you null or null. Okay, just like we randomly use some address, right? We say hashtag 111, hashtag 222, right? Similarly, imagine if this is the address of the first bank account object and the second bank account object. Okay, they are not null. Customer 1, customer 2, they are not null. They have some reference address. Okay. Now let's print the variables from arrays. Okay, as you recall, if you declare an array of size 2, in this group, the first variable will have index of
0.
and the second one will
1.
it will be 1. So how to access arrays? This is how you do that. The variable, take that and do that indexing. First variable is all customer index 0, first variable in the array. The second variable in the array will have
1.
1. Okay, now when you initialize an array, are you declaring the objects or are you initializing the objects as well?
Declaring the object.
Just declaring, no initialization. So if you're just declaring and no initialization, what will be their values?
Null.
Null. Okay, just like what I explained here. You declare the array, it is basically equal to, sorry, you initialize the array. Okay, it is basically equal to declaring a group of variables like this: customer 1 variable, customer 2 variable. Just declaration, not this, just declaration. In that case, they are all null. Okay, so we'll print and see. We just initialized the array and all the variables in this array will be null. There are no references associated with that. No references. Like this, there are no references. All we did was declare a group of variables, not initialize. Okay, so the next question is, if I have declared this variable, how do you initialize this variable?
New
How do we
bank account.
Yes.
Bank account B1 equals to new bank account.
Okay. So you can do that in 2 lines. You can split your one line into 2 lines. B1 equals new. You can do this. Okay, it's the same thing. Instead of writing it in 1 line, you're splitting that in 2 lines. Here we declare, and this is where we assign the values for the first time. Initialization. Initialization meaning the first time, isn't it?
Yes.
So if this is how you declare and initialize individual variables. If this is how you declare and initialize individual variables. In this customer group, we have 2 variables declared, 0 and 1. How do we initialize both these variables in the array? Just compare with the normal variables, not the array variables. Compare with the normal variable. Remember, this
New
is like
customer
one
group.
variable. Customer group of 0 is like one variable. Customer group of 1 is another variable. Just like B1.
And
Customer group 0 equals new bank account.
oh, new bank account. Okay.
That's it. Remember, this is group of variables, isn't it? Rather than declaring 2 variables like this individually, all I did was I did that in 1 line. That's all I did. Rather than declaring a million object like this, I will do that in 1 line. That's what I'm saying. If you just declare the variable, you can use new and initialize them. In arrays, if you're just declaring the variable, you do the same thing. You do the same thing. These two are exactly similar. This and this. Individual variables, customer 0, we are initializing. Individual variable B1, we are initializing. Just like that. Okay. So here we'll do the same thing. After I declare the array, after I initialize the array, I will do new bank account. So what will it print here?
Some address.
Some address for
Customer 0.
Customer 0, the first variable in the array. The first variable, index 0, that has been initialized. How about the second variable?
Null.
That's it. First variable has the value. The second one is still null. Okay. So to properly initialize an array, this is what you do. You declare the array. This is not initializing anyone. All the variables in this array are null. So you have to go individually and do this. Okay, like this. The size is 5. So you need to declare them 5 times. This is properly initializing the array. This is declaring array because all you did was declare the variables. This line declared group of 5 variables. This together is what we call initializing array. Okay, this is a proper way to create array objects. Is that clear?
Yes.
Now you might be thinking, we were trying to avoid this problem. Customer 1 equals new bank account customer. If I have 1,000,000 customers, I need to write this 1,000,000 times, right?
Yes.
Now you do this. Aren't you back to the same problem? You still have to do this part, isn't it?
Yeah, that's what I'm thinking.
Right. So you still have to do this part. So how is that different, right? Rather than writing this new bank account 1,000,000 times, you actually ended up writing 1,000,001 lines. This 1,000,000 plus this array 1,000,000, one more item. So you actually added one additional line to this. So the best way to declare them is use one of the things you learned in past.
Loop.
Loops, control flows. So my question is, which loop is the best one to choose? If you have to repeat this a fixed number of times, I have to repeat this 1,000,000 times, this thing, or maybe 5 times, or maybe 10 times, a fixed number of times. What would you choose?
For loop.
Rather than writing this 1,000,000 times, you can use for loop. Okay, so that's what we'll learn next. Okay, so there is a benefit. So what we'll do, we will use for loop. Int I equals 0, because the first item, the first variable has the index of what?
0.
0. Next, what you need is, the condition is index should be less than what number?
5.
No.
Any specific number? 5, 10, 20? It should be less than whatever size you declare here, isn't it? If it is 2, the last index will be less than 2, isn't it?
Yeah.
If it is 1,000,000, the last number, the last index will be less than 1,000. Basically, it will be 999. So for that, there is a method, length. Take this variable and say dot length. When you say dot length, what you get is the size you declared here. Okay, that way you don't have to write only one at a time. Okay, so what we do is, this is what you do. Okay, and now let's look at this carefully. Now earlier what we did was like this: 0, 1, 2, 3, 4. Okay, earlier this is what we did. We were manually writing individual line, which beats the whole purpose of arrays. Okay, we were doing like this: 0, 1, 2, 3, 4. So if you have 1,000 objects in an array, you need to write that like till 999. So what we did is we improvised. Here, I value is 0. Is 0 less than the array's length?
Yes.
This array, all customer, its length is 1,000. There are 1,000 items in that. Length meaning how many variables are in this array. So yes, 0 is less than 1,000. You enter the for loop. All customers of I, what is the value of I right now?
0.
0. So all customer of 0 equals new bank account. Are you done with this line?
Yes.
Good. What happens after you execute the block? You go back to increment. What is the value of 0 now? Sorry, I.
1.
I becomes 1. Is 1 less than the length?
Yes.
Yes. You enter the for block. All customer of I. Now the I value is 1. All customer of I is equal to new bank. Are we done with this line as well?
Yes.
Yes. Keep doing that until you reach the size 999. Every time in the loop, I will increase 1 at a time. 0, 1, 2, 3, 4. It goes on incrementing by 1. When the size, when the I variable reaches 1000, is 1000 less than the length?
No.
No, it is not less than, it is equal to, isn't it?
Yes.
So the condition fails. When the condition fails, what happens?
For loop exits.
For loop exits. So now, instead of writing that painful thing, instead of writing that like a million times, you did the whole thing with this 2 lines. Okay, you can declare 1000 or even million, a billion. You declared a billion objects and you initialized as well. Not just declaration, you also initialized it. So this is the right way to initialize objects. Okay, not just this one line, but it should be accompanied with the initialization as well. So we literally did this line a million, not million, a billion times using just these 3 array lines. Is that clear?
Yes.
All right. Okay, so imagine I write a for loop here and initialize all 3. Okay, yeah, just for confirmation, you can do a sysout and check for yourself. Check the first item. Check any random item. Okay, we have like a 10 million objects. Okay, it's too much. Let me do 1000. The first index, first variable, some random 235 variable, 590 variable, and let's say the last one, 999. Okay, so randomly I pick the first, last, and somewhere in the middle. Ideally, if you have initialized 1000 bank account object successfully, not just declaration, but initializing every single object, you should never see any nulls. Okay, you should never see any nulls. Everything has a proper reference. None of them are null. Okay, that means we have successfully initialized 1000 bank account variables, not just declared, but initialized. Okay, all right. Now, how does it impact in the memory? Let's see that. Now, this line only did this part. That's all it did. When you declare an array of size 3, what you get is a group of variables declared, just declared, not initialized. Okay, this line gives you just this thing. If you declared and not initialized, default values will be
Null.
null. Now, Let's see how this operates in the memory. For I equals to 0, 0 is less than, what is the length of the array?
3.
3. Okay, length of the array is 3. So this is true. You enter, and here this line will substitute to all customer of 0 because I value is 0. Okay, so this is the all customer. Now this line will substitute to something like this, all customer, I value is 0. So it will substitute the value of I equals new bank account. So when you come across this line, what is processed first?
Create an object.
Equal sign, assignment means right hand side first. What do we have on the right hand side?
New bank account constructor.
New bank account. New bank account meaning we are going to create a new bank account object with default values. Okay, we create new bank account with default values. And this address from the right hand side, when we create the bank account object and we got the address, where does that address go?
To the left hand side.
To the left hand side, which is all customer of 0. So this will not be null anymore, it will be 333. That's what happened in the first loop. After the first loop is done, where do you go?
Increment.
Increment. I becomes 1. Is 1 less than 3?
Yes.
Enter the block, and now this line will substitute to this one. Again, the right hand side says new bank account. What do we do?
Different address object.
Create a new object in different address. What happens next? What happens on the right hand side when you create an object?
Go to the left hand side.
Which is
All customer 1, index 1.
that's it. Okay, and similarly in the last loop we'll end up creating one more, and that goes to the item number 3. Okay, that's how this program evolves. Okay, so my question is, I want to access this balance. How do you typically go about doing that? If I want to do sys out for this one, customer 1's balance.
Sys out all customer dot balance 1.
Listen carefully.
Customer 1 dot balance.
Yes. Okay, don't get too much involved into arrays only. There are a lot of other things as well in this program. There are simple variables and there are array variables. There are both. I specifically asked, I want to access this one, which belongs to the customer 1 variable. So sys out what?
Customer 1 dot balance.
Customer 1 dot balance. That's correct. Now let me rephrase the next question. How do you access the second variable in the array? Its balance. I want the balance of the second variable in the array.
Sys out all customer big bracket 1 dot balance.
Very good. Customer 1 dot balance. You see, there is a slight difference there. Here, you directly say customer1.balance. This is not an array. It's single, one object. But when you want to deal with array objects, you can't say all customer.balance. If you say all customer.balance, whose balance do you want really? There are 3 customers in this array. Is this the right statement if I ask you to get the balance from the array? Does all customer pointing to any balance variable?
No.
No. So the right way to put that is all customer of index. This will give you the balance of index 1. All customer of 1 pointing to 444. Go there and get the balance for me. All customer.balance is not the right way. Remember, you need to use indexes. Array is not similar. Okay, array is not the same as one individual object. There is a huge difference. If you need balance from the array, you don't write all customer.balance. You don't write like this. You're used to write like that when you are dealing with individual objects. When you're dealing with array, you need to be specific. Array doesn't have any balance. Array have indexes. Who has the balance?
Indexes.
Indexes have the balances. Okay, account number belongs to the indexes. The index of 0 has the balance. Index of 1 has the account number. Index of 2 has the balance. The array doesn't have the balance or account number. The array's indexes have the balance and account number. Be very, very clear. So this is wrong. Yes, this is correct. I want the balance of the first variable in array. I want the account number of the third variable in the array. Be very, very clear about this. Why the subtle difference here? When you're dealing with one object, customer 1, versus when you're dealing with arrays, this is the major difference. Is that clear? Is that clear?
Can we do it in the program, please?
Sure. Now, if I ask you to get me the customer number 100th customer's balance, that's what I want. Okay. So typically, this is what you do, right? You cannot say all customer.balance. This will give you error. Okay. The same line when you're trying to print for this individual object. This is individual object reference variable, and this is a group of object. Remember the difference between these two. If I ask you to get the balance of customer 1, you'd straight away say customer 1.balance. Nothing wrong with that. This is perfectly allowed. That's how we did in the past. Okay, because is this one object or group of object? Customer 1.
One object.
Just one object. There is no confusion. It is only one object, not a group of objects. So when I say balance, I get the balance of this one customer, this one object. No confusion. When you're dealing with arrays, array is a group of objects, not one object, but it is a group of 1,000 bank account objects in this case. So if you say all customer.balance, it is wrong. Is all customer one object or is it a group of objects?
Group of objects.
It's a group of objects. So you need to be specific. This all customer is a group of 1,000 objects. Which balance do you need? You need to be specific. There are 1,000 objects inside all customer. So if I just say all customer.balance, you won't get anything, because there are 1,000 balance in individual objects. So to be specific, you need to write the index. If you need the 100th customer in the array, what did you write here? What's the index of the 100th customer?
99.
99. So this will give you the balance of the 100th customer in your array. This is allowed, whereas this is not. This is wrong. Okay, because this is not one object, it is a group of objects. So balance cannot be found there. Okay, you need to be specific. This will give you the value. Okay, there is a subtle difference between how you call variables and method. Now, if you have to deposit $100, listen carefully. If you have to deposit $100 in the 500th customer, how do you do that? Even better, let me ask you simple. If you have to deposit $50 in this customer, forget about the array for a minute. I want to deposit $50 for this customer. Look at the variables and methods and tell me, how do you do that?
Customer 1 deposit.
Balance.
One dot
Deposit
Deposit
amount you want.
$50. Very good. Now apply the same logic to the arrays. My question is, deposit maybe $1 million in the 500 customer in our array. How do you write this?
all customer dot deposit all customer big bracket 499
Very good.
dot deposit million.
There you go. Just like how we were printing the balance for array, we need to be specific. Which item, which index in the array you want to print the balance for? We had to be specific. Similarly, when you want to call any methods, here we are calling variables. Here we are calling methods. You need to be specific. Who do you want to deposit in? Because this is not one customer. It is a group of 1,000 customers. So to be specific, we want to add it in the 500th customer. Index starts from 0. So where will be 500 customer? In 499. That's where the 500 customer will be. So if you want to deposit $1 million in 500 customer of your array, you'd write it like this. Does that make sense?
Yes.
Yes, sir.
All right, so remember how to declare arrays, how to initialize arrays. Okay, this is just declaration. If you want to initialize, loop through, and every object should be declared with new bank account constructor parentheses. Okay, this will do that in a loop. Okay. Second, if you want to access variables or methods from the array, you need to be specific, because array is not one variable, it is a group of variables. So you need to define which item, which variable in this array you want to call the variables or you want to call the methods. You have to be specific. Okay. Declaration, initialization, accessing variables, and calling methods from the array. These are the bullet points. Okay. Always ask the same question. how do you do in a single object? Okay, so this is the comparison. Single object, array. Okay, single object, declaration, and initialization. Array, declaration, and initialization. Okay, this line and this line, they are same. This is one variable, this is group of variable. Okay, accessing the variables in your bank account class through a single variable, customer one, accessing the variable from the array, accessing method from the single variable, customer one, accessing the method from an array. Those are the comparisons. Declaration, initialization, calling variables, calling method. Practice that. Okay. Now, one thing you need to remember is the size is fixed. The size is fixed. If you ever try to access anything outside the given size, you will get an error. Okay, let's do that. This array, all customers, has 1000 variables initialized. So what is the last index?
999.
999. So what if you do like this? Index starts from 0, ends at 999. So is there any variable with the index 1000 in this array?
No.
No.
This will cause an error. Array index out of bound, meaning the limit was, the boundary for this array was 0 to 999, isn't it? There is no index 1000. That is the exception. That is the error. Your array index is out of bound. Click on the very first line. It will tell you where the problem is. Where is the problem? Read that line.
Number 18.
Line number 18. And the class name is? The program name is?
Test student.
Teststudent.java. Teststudent.java. Line number 18.
All customer. Yeah. Sysout print all customer.
This is the line where you got the error. This is the line where you did array index out of bound. The error message clearly points you where the problem is. In fact, you can just click on this. It will take you exactly to the line. This is a problem. Index starts from 0, ends at 999 because we declared the size as 1000. How about this? What will it print?
Print error.
Again error. Index starts from 0, ends at size minus 1. The size is 1000. 1000 minus 1 is 999. So if you're reading anything other than 0 to 999, you get index out of bound. If you get anywhere in the middle, this will not give you the error. It's a reference. It's a variable number 346. Start from 0, 346. Now no more errors. If you fall anywhere before the 0 or after the size number, that's when you get that error. Array index out of bound. Remember that. Okay. All right. So practice this much. Tomorrow we'll need a quick 10 minutes. Okay. It's already late, and I know you guys will lose your focus. Okay. So we'll stop here. Tomorrow we will learn a multi-dimension array and how to copy the arrays. Okay, there is a small topic of 10 minutes left on arrays. We'll do that tomorrow. Okay, but do practice this. Practice static final. Why we need it, when we need it, when do we use it. Okay, now whatever programs you have written so far, go through them and find out which one of these programs has an ideal candidate for final variable, final method, or final class. Follow the rules that I gave you. When do you choose a variable as final, method as final, class as final? And see which one is the ideal candidate. You might have written hundreds of programs until till now. So you might find a use for final or static in some place. Okay, I want to see that tomorrow. I want to see which one you decided to make static or final. Variables, methods, classes. Follow the rules I gave. Okay. After that, I want you to practice declaring array, initializing array, accessing variables from the array, the group, accessing or calling methods from the array. All right, so this is what you need to practice. Apply static final in your previous program, wherever it applies. Follow the rules and practice arrays. Okay, till here. So, any questions?
No, sir.
All right then.